Okay, let's find the sum. So this is summation notation. This will help get us used to summation notation. We've got the sum from n equals 1 to 6, so there's going to be 6 terms in the sum. As long as you start at the lower index at 1, the upper number on top of the sigma is going to be how many terms there are. And then 2/3 to the n. The sum from n equals 1 to 6 of 2/3 to the n. How do I know this is a geometric series in the first place? Yeah, actually that's true. It turns out that the nth term formula for a geometric sequence, not a series, but a sequence, an is a1 times r to the n minus 1. Remember that formula? This is, if you think of n as the input, because r, you're going to know r in any particular problem. You're going to know r and you're going to know a1, or you're going to find them. So n is the input. This is an exponential function. So the nth term explicit formula for a geometric sequence is an exponential function, which you studied in a previous life, right? And if you recognize then, oh, remember, in sigma notation, this is an. If the input is n and you use a to represent the nth term, an is the number that comes after the Greek symbol sigma, right? The summation notation. It comes at the end of the summation notation. So if that's an exponential function, it doesn't matter if it has n minus 1 or an exponent of n. It could be n plus 1, doesn't matter. It's going to be a geometric series. Now, if you don't believe that, you could write out the first few terms to make yourself believe it. So I'm going to do that. This is not part of the problem, but you guys are just getting used to these geometric series, so this is worth doing. Let's write out the first couple of terms. What would the first term in this series be if you plug in 1? 2/3 to the 1 power is 2/3, right? What would the next term be? 2/3 in parentheses to the second power, which is 4/9, but I'm not going to write it that way. I'm going to write it as 2/3 squared. I'm going to leave it like that. What would the next term be? 2/3 cubed. And you could keep doing that until you got to 2/3 to the 6th, right? Now, another way you can see this is a geometric series is just take the second term and divide by the first term, or the third term and divide by the second term. What do you get? So if you take this guy, 2/3 squared, divide by 2/3, when you divide like bases, you can just cancel if you want to think of it that way. You could think of it as 2/3 times 2/3 on top and cancel one of the 2/3 if that helps. Or you could think of it as 2/3 to the 1 power on the bottom, 2/3 squared on top, keep the base and subtract the bottom exponent from the top exponent. Either way, you get 2/3. And if you took 2/3 cubed divided by the second term, you would get 2/3. You'd get the same number every time if you divide a term by its previous term. So it has to be a geometric series. You don't have to do that. All you have to remember to recognize that it's a geometric series is if you see a constant number, that's going to turn out to be r, brought to n or n plus 1 or n minus 1, and there's no other formula involving n, it's going to be geometric automatically. Okay, so with that said, let's see if we can find the sum without actually computing it directly. Let's use that sum formula that we developed. So every time you use it, write it down. Sn is a1 times 1 minus r to the n over 1 minus r. And let the formula be your guide. What's n in this case? Be careful, you guys. This is irritating, but it's a reality. N is being used in 2 different ways. Does everybody see that? Here, and this will happen a lot. Here, n is being used as the index, right? Here, n is being used as really the number of terms that you're adding together. So 2 different ways, and that'll happen. Now, the way you can avoid it if you want to keep the n here in this formula, if you want to avoid that, you could go back to, remember how I called this I earlier? You could do that if it helps you. If it helps you, do it. Doesn't matter, right? Just realize, you don't have to do it, but just realize that n is being used in two different ways. So you got to be careful. So I'll change that to make it a little easier on the eyes. Okay, so what is n sum-wise? How many terms are we summing? 6. So we're finding S6. We're finding S6. Okay? So if we want S6, let's use this formula. What was that first term? I erased it, but you could always find it by just plugging in I. I changed it to I equals 1. What was A1 again? Just plug in 1, and you'll get 2/3 to the 1 or just 2/3. So for this right here in your sum formula, plug in 2/3. And then 1 minus, what did R turn out to be? Okay, now that's not always going to be the case. A1 will not always equal R, but it does in this case. The way to identify R is always going to be the guy you're bringing to the power in the formula. So the base of the exponent is 2/3, so R is going to be 2/3. That will always be true. But if you put like a number out in front, like times 2 or times 3 or something, then A1 won't be the same as R. But in this case, it is. So we have A1 out front, and then 1 minus R, which is also 2/3, to the n. What was n? That was the 6, right? Because we're finding S6. So that's the numerator in the formula. That's the numerator right there. Does everybody see that? Okay, and then divided by 1 minus R, what would that be? 1 minus 2/3. We're going to use, thankfully, we're going to use our calculator to evaluate this, but clean it up a little bit. Otherwise, it won't be as easy as you think to use your calculator if you don't clean it up.
Why is, you said R is the same as A1?
In this case, but not always. Okay?
Why is
Well, I mean, we got R a minute ago by taking the second term and dividing by the first term, and it turned out to be 2/3. That's one way to get it. So you could write out the second term. It would be 2/3 to the second power, divide by the first term 2/3, and you could see that R is 2/3 that way. But there's an easier way. R is always going to be, look at the formula for AN, the guy that you're raising to the exponent. In this case, what are you raising to the I power? 2/3. So that's going to be R. That's the easy way to identify it. Okay, so let's clean this up a little bit. If let's evaluate the denominator first. The big division bar is like a grouping symbol, so you can simplify the denominator and numerator independently. So what's 1 minus 2/3? 3/3. 1 is 3/3 minus 2/3, so 1/3. Yeah? And then on top we have 2/3, then 1 minus 2/3 to the 6th power. Okay. So, now you guys can keep working down in your paper, but just so I can save some screen real estate, I'm going to work to the right. When you divide by a fraction, that's the same as doing what? So dividing by 1/3 is the same as multiplication by 3 over 1, right? So I'm going to take the numerator and multiply it by 3 over 1. Does everybody see how I did that? It's going to make it a little easier on the eyes, because what's going to happen to the 3 over 1 times 2/3 is just going to be 2. So this is as far as you need to simplify it. It'll just be easier to plug in your calculator if you take it this far. So let's break out the calculators. Okay, so I'm going to plug this guy in my calculator. 2, left parenthesis, right above the 8 on the keypad. And then 1 minus, okay, parentheses. In parentheses, put 2 divided by 3. And then the exponent is that little button right there. Does everybody see it? And then, that would be to the 6th power. Then arrow out of the exponent, close parentheses. By the way, different calculators, it could be plugged in slightly differently. So if you have trouble getting the number I'm about to get, let me know. And you hit enter, and you get 1.82 if we round to 2 decimal places.
And then fractions.
In fractions, you could do this. Where is it? There it is. You could go to math and then hit number 1 in your keypad, and it'll change, hit enter, and it'll change the last output to a fraction. So if you want the exact answer, that'd be a good way to do it. So that's 1,330 divided by 729 exactly. And then if WebAssign asks for an approximation to 2 decimal places, you would say approximately 1.82.